Hey guys, it's Raven. I hope lockdown is treating you all right. And if it's not, I hope that me talking about the effect of travel restrictions on the spread of the 2019 novel coronavirus outbreak will make you feel better. Quick overview. I'm going to go through the background of the disease, some methods, results, and conclusions they came to in the study, and a quick discussion. So, COVID 19 is an emerging infectious disease. It's part of the family coronavirus, which is a large family of viruses not exclusive to humans, and it's common in camels, cattle, bats, and cats. COVID 19 is a beta coronavirus along with MERS and SARS, and it is a zoonotic disease as well. So the pathogen is SARS-CoV-2, and it's believed to have originated from bats and spread to humans. Some of the symptoms of coronavirus are fever, cough, fatigue, and shortness of breath, and the symptoms can be mild or severe. But they're very similar to flu symptoms, so it's a little difficult to diagnose. Transmission can occur via respiratory droplets, which are thought to be able to remain on surfaces for hours to days, not the droplets, but the disease. And it can be transmitted through fecal matter on hands that can be you can be touching your face with your hands and it can be transmitted that way. And transmission only occurs when an individual is infectious. So it does not occur during the latency period. So some prevention and treatment background. We've been told this quite a few times now. Prevention, washing your hands, wearing face masks and gloves, and staying home, which is probably a pretty good idea because there's no official form of treatment. So the outbreak began in Wuhan, China, and it was first thought to be a bunch of pneumonia cases with an unknown cause. And now it's realized that the first 40 patients, I guess you'd say, were connected to live animal markets, and now they believe that it spread from live animal markets. So an outbreak was declared on January 30th, and the pandemic was declared on March 11th. So the objective of this study was to provide data on effectiveness of travel restrictions imposed in Wuhan, China, and how it would impact the spread of the disease, and to provide data on the effectiveness of international travel restrictions and reduce transmission. So some assumptions I went into the study with is that the start date of the outbreak is between November 15th and December 1st. The global detection of imported cases is as low as 40%. The R0 value is 2.57. The generation time is 7.5 days, and the doubling time is 4.2 days. So they used global epidemic and mobility modeling to model domestic and international spread of the disease. They had over 3,200 subpopulations in 200 countries and territories. And in each subpopulation, an individual was described as either being in the state of susceptibility, latency, infectious, or removed state. So here are some of the results in graph form of the effect of Wuhan travel ban on the epidemic. In this first graph, we have median cumulative number of cases on the y-axis and dates on the x-axis. So they were able to kind of identify the trajectory of the epidemic at different levels of transmissibility reduction and travel reduction. With no travel ban in Wuhan, and no reduction in transmissibility or travel reduction, there's only about a 3-day delay with the travel ban. which means the travel ban itself wasn't going to be the most effective way to delay the epidemic from reaching other places in China, and that they had to reduce travel and increase transmissibility reduction for there to be an actual impact on the trajectory of the epidemic spread. In the second graph, it's a correlation plot between the model projection, the number of cases with the model projection in each city or province, I guess, and the reported. So between the reported and projected data, there was only a correlation level of 0.75, which we know is decently strong. It's a moderate, almost strong correlation, but it wasn't as strongly correlated as I thought it would be. And from this, they were able to tell that the number of reported cases is much lower than that of the projected cases, and identify that only about 25% of cases in China were detected and confirmed. So 1 out of 4 cases were, but 3 out of 4 were not. So in this last graph, we've got number of observed imported cases from China on the y-axis and dates on the x-axis. And from this, they were able to graph the number of imported cases from China without the travel ban compared to what the imported case numbers would look like with the travel ban and at different levels of reduced transmissibility. And we see about a 77% reduction in imported cases with the travel ban. So here are some more effects of the travel ban. This is on incidences across China. With the Wuhan travel ban, the average percentage of cases averted is ranging from 1% to 58% across provinces in China, mainland China, with an overall reduction of about 10% as an average across mainland China. So to summarize a bit, we see that the Wuhan travel ban is effective at reducing the number of cases in mainland China by a good amount, an overall 10% reduction. Not necessarily as much as we would like, but it's not that effective at delaying the epidemic without reducing transmissibility and other travel reductions being included. And we also see that only 25% of these cases are being detected, really. And that should inform us that we need better testing and more testing to see the accurate numbers, to get a better idea of what the numbers could look like. So here we see the results of the relative risk of case importation. And this, before the Wuhan travel ban, approximately 86% of internationally imported cases were going to be originated from Wuhan. And after the ban, about 80% of imported cases were going to be from the top 10 contributors in China. So instead of Wuhan being the main place for most of the imported cases to originate from, it was going to be other 10 that it had already reached in China. And we can also see from this the most at-risk countries for importation cases. So on the right, after the Wuhan travel ban, we see Japan, Thailand, and Korea as the top 3 for most at risk of case importation. The USA is up there too. And the thickness of the bans on this is how much of a contributor of imported cases would be to each of the different countries. So this is the effect of travel and transmissibility reductions. I've been talking about that a little bit as we go. In these top 3 graphs, it's demonstrating what travel reductions at 40 and 90% look like at different reductions of transmissibility. When there's not really any reduced transmissibility, the trajectory and the median number of exported cases from mainland China is the same. So over time, there's about the same exported cases from China when there's not too much reduced transmissibility. And the same can be said about moderate reduced transmissibility. It's a little lower over time, but it's not a super significant drop. We see the lowest numbers of the exported cases from China when there's strong reduced transmissibility, so when R equals 0.5. On the bottom half of this, we see a visual of daily incidences per 1,000 people in China at different levels of reduced transmissibility. And these circles represent different sizes. So the bigger the circle, the more people per 1,000 people, and the smaller the circle, the less. So at reduced transmissibility level of 1, basically, when there's not any reduction of transmissibility, there's not much of a difference whether there's a travel reduction or not in the number of people per 1,000 people. And we also see that the peak infections are in the same time span. So basically, travel reduction does not have too much of an impact when there's no reduced transmissibility. And it doesn't delay it anymore if there's more travel reduction. And we see the same trend in a moderate reduced transmissibility level. So when R equals 0.75, the size of the circles, so the number of people per 1,000 people, is approximately the same at 40% travel reduction and 90% travel reduction. But now at the moderate reduction of transmissibility, the peak has been pushed towards June 6th instead of the end being at June 6th, like in the no reduced transmissibility visual. And then on the bottom, when there's pretty strong reduced transmissibility, the daily incidences per 1,000 people in China is significantly lower, and it doesn't really appear that the peak would be during this time span, if there even was a peak at all, regardless of what percent of travel reduction. So basically, in conclusion, there's strong transmissibility reductions combined with travel restrictions have the largest impact on delaying the epidemic and decreasing the number of internationally imported cases. So we see less imported cases, less exported cases, and a lower number of cases in general in China when there is a strong reduction of transmissibility. And we don't really see the same reduction when there's only travel restrictions in place or just travel ban in place. So a little bit of discussion on this. These models are essential for public health response planning. They give those in charge the opportunity to see how they should react, what the best way to react is. So travel restrictions are not enough. That tells them that they have to find ways to reduce transmissibility for the epidemic to impact less lives and spread as far. We also see that by providing information to the public on the disease, the transmissibility will be reduced because if more people are educated on how they can help and stay away from the disease, they're more likely to assist in reduction. And I have some questions for you guys. So we've all been living through this, and I want to know, how has the experience of travel restrictions and stay-at-home orders affected yourself and family members? And do you believe it will have a lasting impact? And another is, when do you think travel restrictions and stay-at-home orders /curfews can safely end? Because as of right now, I believe April 30th is the projected time for the stay-at-home orders to end and life to resume as normal, and I want to know your thoughts on that. And do you believe that the US is handling this disease well in comparison to other countries? If not, what could the US be doing better? And that's all I have today. I hope you have a wonderful time with the rest of lockdown. Thank you.